right. Here we go again. I'm going to put this to the bottom. All right, today's lesson is just a review. I'll go through a good portion of it with you. There is a review section on the back that you can do on your own. I'll do the review part with you. It's getting dark outside. I'm going to put my light on my book better so I can see. All right, so hopefully the lesson I did for you the other day helped you a little bit. Get through the lesson and make you feel like we were actually in school, going through the lesson together. So we'll do the same thing today. We'll work through this lesson. And then remember any green, which I don't see any green on this side, but any green, oh yeah, there is some green down here, aren't there? Down in the bottom here. Any green will be extra credit. All right. I did pick up a bunch of work Monday afternoon that some of you left for me. So I have that, and I'll be working on grading that once I get these lessons done. Also, I laid out some biographies. If you didn't get to pick one yet, when you get to school next, pick one off the table. I started with like easier reading to the harder reading. You can pick what you think you could handle or what looks interesting to you. And I think maybe we'll start reading that either next week or the week after. Let me get my thoughts together, and I'll give you plenty of time to read it. But I want you to read a biography, some good nonfiction about some great people in our history. All right, let's get this lesson done. All right, let's name these geometric figures. Real easy. 4 sides all the same. That makes it a square, right? Everybody knows that. My smart 5th graders, no problems. Circle. Learned that in kindergarten. All right, how many sides? 1, 2, 3, 4, 5, 6, 7, 8. What's an 8-sided? Think of octopus. Octagon. And then we have 1, 2, 3, 4, 5. Looks like a house, doesn't it? So you all remember what 5 sides are? Pentagon. Are you watching the Abeka videos too? At least the beginning part where you can get some good review in. And then obviously, this is a right triangle. Oops. All right. Number 2, answer these questions about the geometric figures in exercise 1. I'm sorry, it's a little bit blurry. Can't really tell what the picture you take until you make it big like this. All right, so what fractional part is polygons? Okay, remember, polygons are just simple, closed figures made out of line segments, if I'm remembering correctly. So I think all of them are made with line segments except for our circle. Our circle is not made with line segments. So out of the 5 shapes, 4 of them are polygons. So 4/5. What is that as a percent? 1/5 is 20%. 2/5 is 40%. 3/5 is 60%. 4/5 is 80%. All right. What fractional part has right angles? Well, this square has right angles. This pentagon has right angles, and the triangle has a right angle. So 3 out of the 5. And 3/5 is 20, 40, 60%. What fractional part has at least one set of parallel lines? Well, the square definitely has at least one. Actually, it's 2 sets of parallel lines. This guy has a bunch of sets of parallel lines. This guy has at least one set. This guy doesn't have any sets that are parallel. So I see the square, the octagon, and the pentagon. So once again, 3/5. What percent has at least one set? Oh, wait. Yeah, now they want the percent. And what is 3/5? 60%. Is put in 2 separate lines. What percent is simple closed figures? How many of these are simple closed figures? If you said all 5 of them, you are correct. So 5 out of 5 would be 100%. If you got 5 out of 5 right, 5 out of 5 on a quiz, you got 100%. What percent is hexagons? Do you see any hexagons up there? I don't. That must be 0%. All right, name the type of triangle using the given information. We did this on the last lesson. So all triangles have 3 sides. I see 2 that are the same. Do you remember what you call a triangle with 2 sides the same? If you said isosceles, you are correct. This one has all 3 the same. What's that one called? You remember that one? I wish I could hear you right now. Did you say equilateral? Two of the 3 angles are 30 degrees and one is 60. So we have 2 angles that are the same and then one different. So what would that be? Well, just like this up here, 2 sides the same. 2 sides the same and one different is isosceles. 2 angles the same. Okay. The sides are 9 feet by 9 feet by 9 feet. All 3 sides the same, just like all 3 angles the same, would once again be equilateral. Why? Oh, I think I did this one wrong. This one is wrong. Was anybody screaming at me and I didn't hear it? I'll come back to that. That one's wrong. All right, go down to here. Angles that are 45, 90, and 45. Well, this 90 right away is telling me that this is a right triangle. I do this without looking at my book, and you all know I mess up. All right, let me erase this one because I totally read that wrong. There we go. All right, so if 2 of your 3 angles are 30 and 60, so they want to know what the third one is. So what should we do? Let's add these 2 up. What's 30 plus 60? 90. If a triangle is a total of 180 degrees, and we already have 90, how many's left? 90. Another 90. That makes this also a right triangle. I'm sorry about that. And I will not edit it out because you all know I'm very imperfect. Okay. All right, let's match. I'm going to give you, pause it. Pause the tape or whatever this is, the laptop or whatever you're looking on. Pause me for a minute and do number 4 on your own. Okay. So go ahead and pause it. And then when you come back, I'll give you the answers. All right. Hopefully you tried it on your own. Let's see how you did. Now the 2 little arrows on each end tell me that's a line. The little square box here, my angle, tells me this is a right angle. The 2 dots on each end mean that this is a line segment. These 2 lines are perfectly parallel. They will never intersect. This right here is a polygon. It's a simple closed figure made of line segments. Oh, I'm not seeing this correctly. See, here I go again. That's simply because it's just so small for me. I can't see this one. This one, does this one have a dot here and an arrow here? Let me look at my book. Yeah, that's not a line segment. That's a ray. Who was hollering at me? Okay. This one is the line segment, isn't it? That's the dots on both sides. I feel like this lesson's smaller than the other. I told my husband that, but he said they're the same size. All right, now see, these 2 angles are exactly the same size. They are the same shape. Therefore, they are congruent. These 2 boxes shape, but not the same size, so they're called similar. Did you get it right? Did you do better than me? Okay, number 5. Write the number of degrees in the third angle of the triangle. Measure the two angles are given. All right, so all triangles, how many degrees do they equal? 180. Okay, so if we have 30 plus 60, that's 90. 90 from 180 is 90. 42 plus 55. Do you get 97? I do. I think I'm right. 97 from 180. Well, if I go up 3, that'll take me to 100. 3 plus 80 would be 83. 84 plus 22. I believe if I add those two together, I get 106. Are we right? What is 106 from 180? I'm thinking it's 74. Am I right? 60 and 60. Wow, one more 60 will make 180. That was kind of easy. 45 and 90. That's 135. If I add another 45, that'll be 180. 23 and 72. Do you get 95? I do. 95 up to 100 would be 5 more, plus 80 would be 85. 110 plus 150, plus 55, be 165. So get to 80, I have to add another 15. How's that look? All right, I'm going to switch pages here. Let's see. Is this it? It is. All right. Okay, here we go. Plot the points on the graph. After plotting the points for number pairs in each exercise, connect the points in order, then name the geometric shape. The right triangle in exercise A is done for you. All right, so they did A. Just to save time, I'm just going to go to B. So on B, you want, you want 1, 2. So go over 1, up 2, and make a dot. Then 4, 2. You always go across first. The first number is like what we call, remember I told you, you're going to learn this later. This is the x-axis, and this will be called the y-axis. And the x-axis is always the first number. So you go over 4, up 2. Over 4, up 2. Then you go over 4, up 5. Over 4, 2, 3, 4, 5. And then you go over 1, up 5. Over 1, up 5. And over 1, I don't know why they have that. Why do they have that? Oh, so they do this one twice so that you'll make your line all the way. You'll go back to the beginning part. So what did you just make? It's to me like you just made a square. Kind of fun, isn't it? All right, the next one. Over 6, up 3, over 6. Whoops, I don't want to draw a line. Over 6, up 3. Over 11, up 3. If I go too fast, just pause me. Over 13, up 6. Over 8, up 6. And then the last one is 6 and 3 again. I believe what we have made now is, I'll try to write it small on here, parallelogram. All right, one more. Over 9, up 13. Over 9, up to the 13. That was easy because there's the 13 up there. Over 8 up 11. Either count or you can watch this side. Where am I? Over 9 up 9. Over 9 up 9. And then over 12 up 9. 12 up 9. And then, oh, sorry. Over 13 up 11. Oh, right here. And over 12 up 13. And then the very first one. Oh, 6 sides. What is that? Hexagon. Okay, that was fun. Oh, now we have these lovely conversion problems. All right, here we go. So this is the one you're looking for. You're looking for Celsius. I know that was confusing people before. Doesn't matter which one they write first, whether they put the blank one first or the blank one second. You always look at the one you're looking for, the one you don't know. So we don't know the C, so we need the formula for Celsius. The formula is, in case you've forgotten, I'll go ahead and write these and then you can try to solve them. Okay, so the formula for Celsius is 5/8 times the Fahrenheit minus 32. All right, now don't forget, you're going to put that 86 in the to replace the F. I'm going to let you do this on your own. Do the parentheses first. Do the 86 minus the 32 first. Then times it by 5/8. Okay? I feel like I should do that with you. Am I too nervous? I probably shouldn't be. You guys do just great. Let's see how you do. You can call me if you get stuck. Now this one, you're looking for the Fahrenheit. This one over here, you're looking for Celsius, so you're going to use the first one. The Fahrenheit, on the other hand, is like everything opposite. So now it's 9/5 times the Celsius and then plus 32. So there's no parentheses and it's adding, and you do this part first. You do this part right here. So it's going to be 9/5 times the 50. And then after you solve that, remember, I know I feel like I have to help you. I probably shouldn't. Remember, that's how you do that. Do some cross canceling. Remember that? And then add it to 32. All right, just real quick for solving this equation. Should I help you? All right, this is 6 times Z. So the opposite is divide, because we want to get rid of that and have Z by itself. So what you do over there, you have to do over here. Okay, make sure you check it when you're done. Like I said all the time, I know that you know that that Z is a 6. Okay? But what I want you to do is to do the steps. Now this one right here, I'm going to erase a little bit because I'm getting sensory overload here. All right, this one right here, B, we have 5 meters plus 6 kilometers minus 8 hectometers equals how many meters? Oh my gosh. All right, so this guy, whoops, this 5 is fine because we're looking for meters and he's already in meters. This 6, we're going to have to change to meters. So 6 kilometers, is how many meters? If you go from kilometer to meter, you're doing larger to smaller. Do your hands if you have to. Larger to smaller, you multiply, right? How many steps are between a meter and a kilometer? Right, now over here, I'm going to write meter. 10 meters is a decameter. 100 meters is a hectometer. And 1,000 meters is a kilometer. And I won't, well, we'll do deci just so you remember. Centi is 1/100th of a meter, and millimeter is 1/1000th. So we're starting with the kilometer and we're going down to meter. So if I have 6 and I have 1, 2, 3 steps, not how many numbers, I mean how many words, but how many steps. 1, 2, 3. So add 3 zeros, or you multiply by 1,000 and you get 6,000. So this is 6,000. Now I have to change hectometers to meters. So once again, I'm going from a larger to a smaller. But this time I'm starting here. Get my pen back up. And I'm going down to here. So I'm still multiplying. I'm starting with an 8. But now I have 2 steps. So that's 800. So now I have 5 meters plus 6,000 meters minus 800 meters. And then tell me how many meters that is. This one I think I'm going to do with you. Mainly because I enjoy doing them. And I'm sure you won't mind. Okay? If you know how to do it, and you don't want to listen to me, you can turn it off and just go. You might want to wait till I talk to you about number 9 a little bit. Okay. I feel like I have to help you because we've not been together for so long, and it's easy to forget some of this stuff when it's new. All right. So here's n plus 8 equals 4 times 6. I need to find what n is. The question is, which side can I work on right away? Well, I can do 4 times 6. You all know it's 24. And that should be lined up better than it is. My pen's a little off. All right. Now I need to get n by itself. So what is the opposite of plus 8? Be minus 8. So over here, do minus 8. This side's left with n. What's 24 minus 8? I do believe that's 18. No, 16? How about that? All right. Let's see if it works. So now I'm going to do 16 plus 8 equals 4 times 6. 24 equals 24. Okay? Remember that? I'm going to erase it. You can do that on your own. All right, change these decimals to mixed decimals. All right, this is a little hairy here. So 57 out of 1,000 is 57 thousandths. Okay? So what I want you to do is make the decimal. If something is in the thousandths, how many places after the decimal? Well, the first place would be tenths. Second place would be hundredths. Next place would be thousandths. Remember that? And you have 57 of those thousandths. You don't want to put the 5 over here because that'll make it 500 and something. So it's 57 thousandths. Put a 0 in that spot. Remember that? 19 hundredths. So we have a decimal and we have 2 places after the decimal for hundredths. Well, 19 only has 2 places. So that would be good. 19 tenths, on the other hand, tenths has only 1 place after the decimal. Do you remember that? Well, 19 has 2 numbers, so what do? The 1 will go on this side, and the 9 will go on this side. And then I have, is that 200 and, yeah, sorry, that was my finger doing that. 210 tenths. Once again, if you have something in tenths, it's only 1 number after the decimal. 210 has 3 numbers, so 2 of them will go on this side, and 1 of them goes over on this side. I think I'm going to quit there. See how you do on the rest. I did quite a bit with you, and that should really help you get through that lesson. The more we do this together, maybe the less I have to help you on some of this. We'll be remembering it. I this. Talk to you later.